Hello everyone, in this video we are just going to build our first ever LED blink project in our TIVA C series microcontroller TM4C123 by connecting external LED. Let's get started. So we did this project in the previous video itself by the help of the CMSS files, but now also we are just going to do the same thing but with the different pins. So now we are just going to connect an LED to the PA2 of the microcontroller, and then we are just going to configure that pin as output, and then we will be connecting an LED to that pin with the help of breadboard, and then we will be viewing that output. So I'm just opening the KEIL microvision. So I'm just going to build the project from the scratch by including all the CMSS and startup files. Click on the project, new microvision project, and go to the respective folder. And here type in the project name and click on save. In this tab, select the device, that is nothing but TM4C123 GH6PM. Just type in the device name right over here in the search box so that this device will be listed. Double click on this and then click on OK. Here in this manage runtime environment tab, which is a very important tab, you just want to select the CMSS core, which is much needed in our project, and then we just want to select the device startup code. So tick these two checkbox CMSS, we just want to select the score, and in this device tab just select the startup and then click on OK. You can see the project has been successfully created. Now right click on this source group and click on create new item to the source group. Here click on the C file, that is the .c file, and give the name as main.c, since we are creating the main.c file for our project. Here in the main.c file, as usual, the first and foremost thing that we want to do is we just want to add the header file required for our project. Right click on this and then hover over this insert as include file and then click on this tm4c123.h. You can see the device header has been added. I'm just opening the document. So this is the CMSS file that has been generated for our project by the KEIL microvision IDE. Now let me just start writing the program by starting with int of main return 0. And inside the main function, as usual, we are just going to create the infinite loop, which is the repeatably executable statements which needs to be written inside the main function. And this is the one-time executable segment of the program where we will be writing all the configuration lines, and this is the repeatably executable statements of the program which will be executed again and again until the microcontroller is stopped. So these two are the main segments of the embedded program, as I mentioned before. And now we are just going to start up by writing our program. As usual, I am just going to open the dataset of the microcontroller. And I am going to the pinouts of the microcontroller. So this is the microcontroller that we are having in our TIVA C series launchpad TM4C123 GH6PM. It is a LQFP 64 pin packaged controller. That is, it has totally 64 pins. So here you can see we are having 16 pins on one side and we are having totally 4 sides. So it is a quad IC. And here in this microcontroller we are having totally 6 different ports, starting from GPIO port A to GPIO port F, and each port is holding 8 different pins. That is, if you take the port A, we are having totally 8 pins starting from PA0 to PA7. You can see here this A port starts right over here, and PA0 is the 17th pin, and it goes on, and PA7 is the 24th pin. And similarly, port B is also having 8 pins. Starting from PB0, 45th pin, we are having PB4 and 5 in the pin numbers 58 and 57, and PB6 and 7 are located in the pin number 1 and pin number 4. And similarly, we are having PC port, that is GPIO C. It is also having 8 pins. PC0, 1, 2 and 3 are located from pin numbers 49 to 52, and PC4 to 7 are located between pin number 13 to 16. And similarly, GPIO D is located somewhere right over here from pin number 61 to 64. We are having PD0 to PD3, and then we are having 43rd pin as PD4, 44th pin as PD5, and PD6 and 7 are located in 53rd pin and 10th pin. 10th pin is the PD7. And similarly, we are having 8 pins starting from PE0 to PE7 for GPIO E, and similarly we are having 8 pins for GPIO F starting from PF0 to PF7. So we can use all these pins as digital IOs, whether as digital inputs or digital outputs. And now we are just going to use the PA2, that is right over here. You can see PA2 is located right over here in the pin number 19 as output, and we are just going to connect a LED for blinking the LED using this PA2. And now we are going to connect an LED to this pin number 19 of this microcontroller, that is PA2, and we are just going to toggle the state of that pin by configuring that pin as output. So that is our task for this video. I am just going to minimize this. I hope you understood the basic pinouts of this microcontroller. All the pins can be used as digital pins, and also it has some special features that we will see in the future videos when we are discussing about the specific peripherals of this microcontroller. And now, first and foremost step that we want to do is we just want to enable the clock for the GPIO port required. So as I said, we are just going to connect the LED to PA2. So PA2 means it is related to GPIO A. So for enabling the clock for the GPIO A, I just want to go to the RCGCGPU register, right? So RCGCGPU register, let me just find it. Go to the register map of system control so that you will find that RCGCGPU register. So here it is. So here is the RCGCGPU register, and in this register you can see this is the register for enabling the clocks for all the GPIO ports of the microcontroller. And here in this you can see clearly the 0th bit, it is a 32-bit register, and in this register the 0th bit is useful for enabling the clock of GPIO port A. That is, if I write 1 to the 0th bit, it will enable and provide the clock for GPIO port A in run mode. So I just want to set 1 to the 0th bit of this register, and rest all the bits I will be giving the value 0. That means 0 from 31st bit of this register till the first bit, and only 1 for this 0th bit. So for accessing the RCGCGPIO, I just want to use the SYSCTL pointer as we did for the LED blink in the previous lecture, and pointing to that I am just going to use the RCGCGPIO. Just type in the register name, and I am going to write the value 0x. As it is a 32-bit wide register, I am just going to write 7 zeros, 0 0 0 0 0 0 0 and 1 at the end. So this 1 will definitely enable the 0th bit, leaving all the other bits available in the register to be 0. So this line will automatically enable the clock of GPIO A. On the next line, I am just going to digitalize the GPIO port A. As we are going to use a particular pin as digital output, we just want to enable or digitalize the particular pin with the help of a register called DEN. So that can be found in the registers of GPIO, that is general purpose input output. Go to the register description. So this is the register, GPIO digital enabled register. So in this register you can clearly see that each of the LSB 8 bits is assigned for a particular pin. That is, if I write 1 to this 0th bit, the 0th pin corresponding to that port will be digitalized. And if I write 1 to this first bit, first pin of corresponding to that particular port will be digitalized. So in our case, I am just going to use the pin number 2, as we are going to use PA2 for connecting the LED. We are just going to digitalize the pin number 2. So I am just going to write 1 right over here and 0 to rest of all the bits. So 0 0 0 0 0 0 goes on like this, and at the LSB part I will be writing 8 bits of data, that is 0 0 0 0 0 1 0 0. So 0 0 0 0 in the MSB part of the 8 bits will give me the result of hexadecimal data 0, and in the LSB part I am having the value 0 1 0 0. So 0 1 0 0 is nothing but 4 in hexadecimal. So I am just going to give 0x04 for enabling or digitalizing the pin number 2 in port A as digital pin. So I am just going to use the pointer here to be GPIO A. Since we are using the port A, I am just going to use this pointer GPIO A. If you are using a different port for connecting the LED, you just want to use the different pointers like GPIO B, C, D, E, F. We just used F. We just did that in the previous lecture. Now I am just using the GPIO A. So I am just going to point to the register of DEN and I am going to write 0x04. As we discussed, this 04 will be digitalizing PA2, will be digitalized. Or I can also write a 32-bit data like this 00 00 00. It is not a problem. And the third thing that we want to do is we just want to set the direction for that particular pin. So we just want to configure a particular pin as output before using that pin. So we just want to decide whether to keep a particular pin as input or output, whether to configure a pin as input or output, right? So that can be done with the help of a register called GPIO DIR register, that is the direction register. So here also we are having LSB 8 bits open and all the other bits reserved. So it is also a 32-bit register. All the registers available in this microcontroller are 32-bit registers. And now here you can see, if I write 1 to the 0th bit, the 0th pin corresponding to that particular port will be configured as output. So 1 means output and 0 means input. That is the concept. And if I write 1 to the first bit of this register, the first pin corresponding to that particular port will be configured as output. And if I give a 0 to this first bit, the first pin corresponding to that port will be configured as input. So in our case, I just want to configure the second pin as output. So I will be writing 1 to the second pin and I will make all the other bits 0 in this register. So I will be getting the same value as GPIO DEN, as I am configuring only the second bit, that is the second pin. So here I am just choosing the DIR and I am going to write the same value, that is 0x04 for configuring the PA2 as output. So here also I am just going to provide a 32-bit value 000000 output, and that's it. Now the configuration segment has been completed. We have enabled the clock for the GPIO port A and then we have digitalized the second pin of the port A, and then we have made the second pin of the port A as output. So these three things has been done, and now we are just going to turn on the pin number 2, and then we will wait for a particular time, and after that time we will turn off the same pin number 2, and then again we will wait for a particular time. That is, we are just going to implement the blinking process inside this while of 1, so that the process repeats until the microcontroller is stopped. So I am just going to do that with the help of a register called GPIO data register. So this is the main important register which is useful for writing data to any particular port pin. So this also will be having 8 LSB bits out of all the 32-bit wide register, and if I write 1 to this particular 0th bit, the particular GPIO pin corresponding to that GPIO port will be made high, and if I write 0 to the same bit of 0, the particular pin of the GPIO port corresponding GPIO port will be made low. So this is the concept. In our case, we are just going to turn on the pin number 2, and we are just going to turn off the pin number 2. We have already learned some methodologies for turning on a particular bit in a register without disturbing other bits, and turning off a particular bit in a register without disturbing other bits using the bitwise operators, right? So we are just going to follow that right over here. So I'm just going to use the GPIO pointer, and I'm going to write to the GPIO data is equal to GPIO data or of 1 left shift of 2. So this will turn on the PA2 pin, and here I am just going to give a delay, a particular delay. Let's take it to be something like this, a rough delay, and after the delay I am just going to turn off the same pin. So for that we just learned some technique, right? For turning off the pin we just used the ampersand operator, ampersand of negation of 1 left shift of 2. So this will turn off the PA2. So if you want any other bits to be turned off or cleared in that register, you can provide the bit number right over here to 0, 1, 2, 3, whatever you want, you can give here right over here. I hope you remember this concept. And again, after this, I'm just going to produce a delay right over here. This is a rough delay. So the concept is the same that we did in the previous video. We are just going to turn on the PA2 and wait here for a particular delay, and after the delay we are just going to turn off the PA2, and then we are just going to wait here for a rough delay, and this process continues because it is available inside the infinite loop of the program. So until the microcontroller is stopped, the LED which is connected to PA2 will be blinking. So this is the process. So I'm just going to copy the delay function that we wrote in the previous video. That is a simple loop delay function, and I'm pasting it right over here in the top of this main function, and that's it. Now I'm just building this program. You can see I'm getting 0 errors and 1 warning. That warning is due to statement is unreachable due to this return of 0. So that is not a problem, just leave that. And now I'm just connecting my Tiva C series launchpad to my PC through USB cable, and I'm going to dump the program to my microcontroller with the help of this download icon right over here, or press F8 in your keyboard. Sorry. So for dumping, just click on this options for target, and in the debug tab select the Stellaris ICDI drivers. I just taught you to install these drivers, right? So select that and click on OK, and now click on this download button. The flash has been successfully dumped to my microcontroller. Let us see the output in my hardware. Now here you can see this is the TIVA C series launchpad development board, and in this breadboard I have connected an LED and a 1K resistor in series with the anode of this LED. So to this end of this resistor I will be connecting the PA2 pin of the microcontroller, and to the cathode of the LED I am just going to connect the ground of the microcontroller, that is the ground of the circuit. So let me just find the PA2 that is available in my TIVA C series launchpad. You can see here is the PA2 mentioned in the development board. So this pin is corresponding to the PA2 pin of the microcontroller. So I am just connecting the jumper to this pin, and I am going to connect the other end of the jumper wire to the 1 kilo ohms resistor. And now I am just going to connect the cathode of the LED to the ground of the development board. So here is one of the ground. I am just going to connect it to the ground of the development board. You can see clearly here I am having one ground right over here. So I am just connecting the jumper wire to the ground pin. And that's all about the circuit. I have already dumped the program as I showed you, and now when I connect the TIVA C series launchpad to my PC through USB cable, you can see the LED which is connected to PA2 of my TIVA C series launchpad is blinking. So this is the output that I got in my hardware. See you in the next video. Thanks for watching.